Back, everyone. Today is Wednesday, April 29th, and you will need your math book open to page 436 and a pencil for today's lesson. So, yesterday in our Google Slides, you learned about how to find sample spaces for compound events. And yesterday we talked about creating an organized list, making an area model, or the book likes to call it a table, or creating a tree diagram. And so these three displays that I have here on the screen are showing you all the different ways of what your results are for when you toss two coins. Excuse me. So your organized list is, you could have heads, heads, you could have heads and tails, tails, heads, tails, tails. Here is using our table, and again, using our tree diagram. The blue indicating what your first toss or your first coin is, and the red being indicated as the second coin. All right, so we're going to jump in and just start talking about organized lists. For each condition, use an organized list to help us show all the possible flavor combinations for scoop 1 and scoop 2. So they're talking about frozen yogurt. And question A wants us to identify that scoop 1 and scoop 2 can be either the same flavor or they can be different flavors. So if we look at what our flavor options are, we have peach, strawberry, and banana. And our goal is to make an ice cream cone that has 2 scoops on it. And so they can either be the same or they can be different. So for question A, just like we did in yesterday's video, we want to identify each of these using a letter. We can use P for peach, S for strawberry, and B for banana. And I'm going to start with peach. And you'll notice that scoop number 1 is the one that's touching the cone, and scoop number 2 is the one that's at the top. So my flavor choices can be peach with strawberry. It can be peach with banana. Or, don't forget, I can have peach and peach. So that is when peach is the first flavor, the one touching the cone. We have to continue on because I could have strawberry being the flavor that touches the cone. So I'm going to have strawberry peach. I'm going to have strawberry banana. And then I will have strawberry strawberry. Now, some of you might think, Mrs. J, peach strawberry and strawberry peach are the same exact answer. They're not. Remember, this first letter is scoop number 1, and the second letter is scoop number 2. Scoop number 1 is touching the cone, scoop number 2 is not. So peach strawberry and strawberry peach are not considered the same. So I started with peach, I started with strawberry. Well, maybe I want banana to be at the base of my ice cream cone. So I can have banana peach, I can have banana strawberry, and then I can have banana banana. And I need to go back here and put another B in there for banana. So question A wants us to list what's our organized list to show all the possible flavor combinations for scoop 1 and 2. And so when we have either the same or different flavors, you'll see we have a total of 9 outcomes. Question B is now asking us scoop 1 and 2 must be different flavors. So we can come back here to our organized list that we just used, and we can eliminate the ones that have the same exact flavors on them. So peach, peach, strawberry, strawberry, and banana, banana would be removed. And so this time we would have a total of 6 outcomes. I am going to stress that when you are working on your assignment today, that you read carefully through the question. A lot of people think this is really easy, and because it's multiple choice, they think that they're gonna be able to fly right through it. Notice the difference between these two questions. Same flavor or different flavors. In A, we could have same or different, but notice in B, they had to be different flavors. So there's a big difference between how these two questions are worded. We are going to skip over the bagel question at this point in time. Actually, no, we're not. I'm going to talk about this bagel question because I do believe you have a question that's similar to it on your homework today. So 3 friends are buying bagels and they are choosing from the kinds that are shown. They buy 3 different kinds. So you have 3 different friends. You have friend number 1, you have friend number 2, and you have friend number 3. And each friend is going to get a different flavor. So we have to make an organized list to show all the possible combinations that our 3 friends can get. And so again, 1 is friend 1, 2 is friend 2, and 3 is friend 3. So I'm going to start where friend number 1 gets plain bagels. Now notice they buy 3 different kinds. So should anybody else in this group also be picking out a plain bagel? And the answer to that question is no. Nobody else should be getting a plain bagel. So we'll just go in order. So if friend 1 picks out plain, then friend 2 can get a sesame, and friend 3 could get cheese. Again, friend number 1 likes that plain bagel. Friend number 2 likes that sesame. Friend number 3 now can choose onion. We have friend number 1 choosing plain again. We've already done all the flavor combinations where friend 2 chooses sesame. So friend 2 is now going to choose cheese. Friend 3 is going to go for the sesame. Again, plain. Friend 2 gets cheese. Friend 3, not sesame, but onion. Friend 1, again, always starts with plain. So we've had plain for all of friend 1. Friend 2 has started with or has had sesame, or they've had cheese. So now their option is onion. Friend 3 can now choose between the 2 that are left. So we got sesame with onion for our second friend, and then finally cheese. And if we look at this whole list, how many do we have when friend 1 always chooses plain? And we have 6. So now what we would do is we would continue with this table. And we would do the same thing, friend 1 and 2 and 3 under sesame. So friend 1 would be sesame every single time. We would do it here at 2 and 3 for cheese. And over here again for onion. And let's think about this for a second. Take a crazy guess. How many outcomes do you think we would have under sesame if friend 1 chose sesame every single time? How many options would we have here, or outcomes would we have if cheese was what friend 1 chose? And the same with onion. Well, I'll tell you this. It's the same as what we started off with at the beginning. Each one of these columns will give us a total of 6 outcomes. And so because I have 1, 2, 3, 4 tables, or 4 different types of bagels with 6 different outcomes each, our final answer is 24 outcomes. Okay? The second type of problem that you learned yesterday in your Google slide was to create the table or an area model. And I stressed yesterday, and I'm going to stress it again today, that your outcome for step number 1 always has to be located at the top of your table, and the outcomes for step 2 need to be on the side of your table. So I'm spinning a spinner and flipping a coin. Some of you may have had this yesterday. And so when you create your table, remember the outcome for step one has to be listed first. So this is going to be reds with head, red, and tail. Green, heads, green, tails. Yellow, heads, yellow, tails. Blue, heads, and blue, tails. And it wants to know what's our total number of outcomes. And again, we can count this 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 outcomes. All right. Now, if I wanted to say, what is the probability that we would spin blue and land on heads? You would use this table to help you find how many times do we see the B for blue and the H for heads. Looking at this table, it shows up just once, and there was a total of 8 outcomes. So that, ladies and gentlemen, is what is the probability of that event occurring. And we will talk more about probability next week. So let's look at the question that you have in your book. And it says a clothing store sells sweaters in V-neck, crew neck, and cardigans. And you have the color choices of blue, gray, or red. And it wants us to figure out how many different sweater choices that we can create. So again, we'll put our table together. And we have 3 different types of sweaters. You have a V-neck. You have a crew neck. I'll do CR for crew. And you have a cardigan, which I will do CA. So again, this is my first event. And this is important for you to remember because you will be given blank tables like this on your homework today that you will have to fill out. And you have to remember that the first event is what needs to be listed first. So then my color choices are blue, gray, and red. So again, imagine this is your homework. And as you're filling in this table, you have to remember that your first event is listed first and your second event is going to be listed second. So V-neck in blue, V-neck with green, V-neck with red, V-neck crew. Whoops. See, look, I'm trying to rush through this. I just made a mistake. Let's try that again. That's crew neck with blue, crew neck with green, and crew CR with red. And then cardigan, blue, cardigan, green, cardigan, red. And how many total outcomes? We have 9 outcomes. And the last type that we talked about yesterday was tree diagrams. And one thing that I want to point out to you is your tree diagrams are going to look very different today in your homework assignment. Yesterday, when you looked at your tree diagrams, you started at the top and you built your tree down. We are actually going to build our tree from left to right. So I have an action, which is making a snack. And step number 1 is to choose crackers or pretzels. So I'm going to use C for crackers and P for pretzels. Step 2, is to choose apples or oranges. So if I choose a cracker, I could get an apple or I could get an orange. But if I had decided to go with pretzels, I could have apple or orange. And finally, I have types of drinks to choose from, which is milk, juice, or water. And so we have milk, juice, water. milk, juice, and water. And we're going to continue to build this off. As you can see, we're building a tree. Each branch is taking us to another choice. Milk, juice, or water. And then we have this column right here, which is our outcome column. And our outcome column is where we follow our branches and we list every possible sample space that we could have. So C-A-M, C-A-J, C-A-W, and we'll keep on going. And so we want to know how many outcomes do we have, and we can count right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 outcomes. Now, one thing that you noticed in the video yesterday is you can also find the number of outcomes by counting what I like to call the roots of the tree. So if you count the very bottom of your tree, or in this case, the side of your tree, you can find out how many outcomes you have. So again, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And that is creating a tree diagram. Let's go ahead and answer that last question, or the question at the top of page 437 in your book. On the school bus, 2 students sit in each seat, one by the window and one by the aisle. And what they're asking us to do is to make a tree diagram to show all the possible arrangements of 6th, 7th, and 8th graders sharing a seat. And then we can list these possible arrangements in an outcome column. So here's what we're going to do. So when you think about it, when you get into the seat in the bus, your first place that you would sit is by the window. And if you're the second person to sit in the seat, then you sit on the aisle. Okay, so 6th graders could sit by the window. I could have a 7th grader by the window. I could have an 8th grader by the window. Now, sitting next to that 6th grader could be another 6th grader, a 7th grader, or an 8th grader. Again, 6th grader, 7th grader, 8th grader, and finally 6th, 7, and 8. And so it asks for an outcome column. And so that would be a 6 and a 6, a 6 with a 7, a 6 with an 8, 7 with a 6, 7 and 7, 7 and 8, an 8 with a 6, an 8 with a 7, and an 8 with an 8. And how many total outcomes do we end up having? Again, we can either count the base of our tree or count all of our outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a total of 9 outcomes. So again, I cannot stress enough how important it is going to be for you to read the questions carefully on your assignment. Many mistakes are going to be made because you're not reading what the question is asking for. Take your time, read carefully, and I hope to see you guys next week.